In this video, we are going to be making a Hello AR clone, or our own Andy placer. Now, the Hello AR included with our Google AR was a very good Hello AR because it showed a lot what we can do, and it's also complex. So by replicating it, we can actually learn something. So we're going to be doing that because before I start teaching you the API, I want you to even know how this works. Okay? So right now, I'm just going to go through all the steps to set up the project, and I will skip it or speed it up. Okay guys, it seems as if we are ready to begin. So, the first thing we will need to do is save a new scene. And in our scene, we will be working from there. So, actually ARCore is mostly code, but there are some things that you have to do in scene view. So first, let's save this as our main scene. And whatever I did to that, let's just delete it. Okay, so we don't need a directional light, and we don't need that. So what do we need for our scene? So, if you open up your Google ARCore, you get two prefabs, ARCore device and environmental light. So environmental light, when we place our object, as you saw in Andy, it gets a light that is like what is our ambient light. So this object is called upon when we call upon our environmental light. So it basically houses the environmental light script. Our other prefab, slightly more complex, is our ARCore device. That has a child first-person camera. This is basically our camera for our whole thing. And as you can see, that's our camera preview. Empty means that we're just going to be seeing straight from our whichever phone you're using camera. And then here you see tracked pose driver and session. We're going to learn more about these later. But for tracked pose driver, it's basically just settings. Okay? So now we have that. And what we also need is a controller where we will add our game, or really ARCore controller. So that will be our script. And that is all we need. We can also add a canvas if we want to tell us when we have found our plane. So canvas. And let's align our canvas by going here and then setting the resolution you want. So you may need to look this up on the internet, but I just use an S8, so that's 1440 width by 2960 height. And then if we're working with the horizontal ARCore app, it'd be 2960 by 1440. Or if you're using something like a pixel, it'd be like this. So I'll set that and zoom out a little. Make it 2D. Okay, and then all we need now would be a UI text. Just tiny. So let's take the text and make it a bit bigger. And let's set the text to searching for a plane as our default, and let's set our font size. I think 92 is usually good. Yes. And we don't have any light in our scene, so it's looking really bad. So environmental light is an object holding a script. But since it's looking really bad, let's just make it directional light. Okay, that's it. And just so you know, ARCore uses meters as its distance. So if we were to place an object, say 1 meter away from where we started, and 000 is where we open up the app. So if we set this to like 1, so the light would be 1 meter away from where we start our app. But there's some things called anchors, and I'll show you that later. So that makes this a bit more complicated. But yeah, directional light just makes our scene look better. And that is all we need. So at this point, we can open up our scripts. Okay, so we have an empty thing. So the first thing we will need to do is add using Google ARCore. That will give us access to this whole SDK. So let me show you how this works. So this is to get access these scripts, or really these scripts, which we shouldn't be using at all. That is Google ARCore.helloAR. Now if we go into our SDK, some of these scripts are Google ARCore, like frame, namespace Google ARCore. And these use Google ARCore internal, which we shouldn't be accessing. We should be accessing the Google ARCore internal stuff through our through our class. And we are going to be learning more about that later on. But just to let you know that. So the first thing we need, obviously, is our camera. So public camera cam, and we should actually have our void start method. Okay, and then cam should be equal to camera dot main. Okay, and then let's just go back into our Unity and make sure to set our child main camera. So that camera.main returns this. Okay. Next, let's go back into monodevelop. And then what else do we need? So we need our Andy prefab. So public game object Andy prefab. We could just place cubes if we wanted. I mean, I guess we could. It wouldn't stop us. Just why not place Andy's? But yeah, if you want to make this cube prefab and then just make an empty cube object, you can do that. I don't care. We're not going to be working on this project past this simple tutorial. And that should be all that we need right now. And we can deal with our text later, but I guess we can just add this, and then we need Unity engine.ui. So using Unity engine.ui. And then public text searching text. Okay, and then let's first run this. Fill in everything. So our controller. So I don't know if you guys see it, but I see squirrely lines when it's building. So if you just see my mouse like not moving and I'm waiting for something, it's building. So right now we can set our first person camera there if we want. Our Andy prefab. So in our Hello AR example. Or again, you can just make a cube if you want. Andy. And then our text. So in this tutorial, I'm basically going to be overwhelming you with just everything you need to know to make this app. And I'm going to be explaining everything to you. And you may not understand everything, but then as we go through, make more apps, learn about the API, you will. So don't be too stressed out if you don't understand what I'm saying. And I hate these annoying comments. Okay, so the first thing we want to do is going to be the only time I tell you go into the Hello AR example. Because there are two functions that I want to access. So in our Hello AR controller, grab quit on connection errors, and more importantly, show Android toast message. The reason we're not writing these out is because these are more copy-paste things. You don't need to understand them beyond me explaining them to you. Basically, this uses a class called session of Google ARCore, which checks our connection state, and is checking if the device isn't supported, if the user is rejected. Like, say, when you launch the app, it's like, can this app access the camera? And then this is connect to service failed. So that's just miscellaneous here. So first thing you want to do in every update is to underscore quit on connection errors. And show Android toast message is extremely useful for debugging. So it will come in handy in the future. So after that, we need to make sure that our screen, so that's a Unity class, dot sleep timeout is equal to 15. So basically 15 seconds without tap and then. Okay? So what do we need after that? Let's talk about displaying if we have a plane or not. So you're pointing it at your floor, and it's pretty obvious if that's the plane. And we have a thing to display a mesh over that. Now for most apps you don't need to display that mesh, because as ARCore improves, it'll detect planes much faster. Also, it will take a little while and a lot of math to get the mesh done. So if you want to learn more about the mesh, just go into your tracked plane visualizer, and then you'll see it's a bunch of triangles and stuff. Okay, so let's set a boolean, and this is going to be in our update function, so it'll be destroyed every time update is done. Show searching UI, and then let's default that to true. Okay, so now we're going to be using something called frame, and you just saw it. So frame, you use frame to access the current planes. So if you want to see if you've detected a new plane this frame, or if you detected or if you still have any frames or planes this frame, you would use frame.get all planes, and then this uses ref. So we would need a list of tracked planes. So let's just make that list of tracked planes is equal to list of tracked planes. Okay, or I guess you put new, and then ref tracked planes. So ref is again a C# thing. Okay, and then if, so now we'll have an if tracked planes dot length. Which one is it for lists? Oh, so dot count. Okay, so it's capital. Dot count is greater than 0. Then we can set our searching text to found, or searching text dot text to be equal to found plane. Else we can set it to searching text dot text is equal to plane, searching for plane. Okay, now after that we need to set up our function to place an object. So first thing we want to check is if there is a touch. So that is very simple. If input dot touch count is less than 1, or if or input dot get touch 0 dot phase not equal to touch phase dot began, then return. So what are we doing here? So if there's no touch, or if you're holding on it something, it's not even going to allow you to get into the next section of touching it. And let's just clean this up a little bit. Let's make it touch, and then let's set that to afterwards here. Touch is equal to input.get touch 0. Okay, so code is a little bit messy. We can clean it up later. So now, what we need to do is we need to check if we can place our object. So since we only want to place it on flat surfaces, okay, first we want to create a trackable hit flag raycast filter. So this is basically going to be used in a function called session.raycast, which checks if where you placed there is what you are searching for. So what are we looking for? We want a trackable hit flag dot a plane within bounds, or only one of these, and then or trackable hit flag dot plane within polygon. This will only place it where we detect a plane. Okay, and then you'll see where that is used now. And we also need a trackable hit. Okay, so now here's the main thing. So if session.raycast, so this needs a filter. So for example, if we want to choose just anywhere, we would use point cloud. If we want a plane, but like a plane that extends forever, we would use trackable hit flag dot plane with an infinity. Or if we, I guess that'd be all. So if session.raycast, okay. Now m underscore first, so we need our cam dot screen point to ray. So first we need array, and then touch dot position. This is a Unity command. Okay, so then after we get our ray, we need our filter, so that's going to be our raycast filter. And then finally, we need to out to our hit. And then that leaves a vector 3 in world space. So for example, if I clicked right in front of me, that might be like, if it's on the floor, it might be like negative something for y, and then like positive x or y, or negative x or y, or something like that. So basically, it would give me a vector 3 for my trackable hit. Okay, so now here's how you place an object. So the first thing you need is a anchor. And what does an anchor do? So an anchor is basically a point in 3D space which ARCore tracks and holds. So if I place an anchor at 1x in front of me, that would be a spot 1 ahead of me. And if I place an object as a child, and then as I move around, ARCore would keep that anchor relative to me. And if I keep a child, say a cube or an Andy object, as a child of that anchor, then as I move around, the anchor would move around, and so would whatever 3D model I have under it, meaning that everything seems to stay right where it is in the 3D world. So you saw that. So that's basically what anchor does. And we create that by session.create anchor, and then hit.point. There's also hit.plane. We're doing hit.point. And then this quaternion.identity. Rotation does not matter for anchors. And my keyboard is all messed up. So are my fingers. So now we need our Andy object. So var Andy object, and that's Andy prefab at the top, is equal to instantiate. Now this is a Unity method. However, we throw some ARCore twists on it. So the first thing is we'll need our Andy prefab. Then our next we want a vector 3. So hit dot point. Then after that we want our just a quaternion dot identity. And then afterwards we want our anchor dot transform. So as the child of that, as the anchor moves around to stay in relative place with ARCore, this will move around. Afterwards, we can just set Andy object dot look at if you wanted to look at it, or dot transform dot look at. And then all we need is our first person cam dot transform, and that should be all. Now let's just build it to make sure we have no errors, and that is good. So I hope you guys enjoyed this, and I will see you guys in the next video.